Hello, and this is going to be the video review for some questions for the normal curve and probability topic, which was found in Module 9. So within this that we received on Tuesday, I'm going to just do a couple. So let me scroll down, and I'm going to do number 4, 5, 6, and 9. So let's start with number 4. So will last for at least 50 hours. I know that seems important, but that's just their guarantee. But when they actually do the research, they find that the mean battery life is 60 hours, and it has a standard deviation of 5 hours. So that's the mean, that's our standard deviation. Sketch a diagram showing the normal curve with 3 deviations in both. So it's a bell curve. Right in the middle is our mean, which is 0 standard deviations away. And then a normal curve has 3 visible standard deviations. Anything past that is just too small to even pay attention to. So we're going to have 1 standard deviation this way, 2 standard deviations, 3, -1, -2 standard deviations, -3 standard deviations. Cool. We actually know the values that we could input. So the mean is 60, and if our standard deviation is 5 hours, 1 standard deviation away, that'd be 65, 70, 75, 55, 50, and 45. Great. So find the percentage of batteries that will have a lifetime between 60, 5, and 70 hours. So essentially, what happened there? This percentage. So how we're going to do it, we're going to find the area under 70, and then we're going to find the area under 65 and find the difference, because then we're just left with that gap. So using our z equation, z-score equals, it's on your formula sheet, the data point minus the mean all over the standard deviation. So that's going to give us a z-score of 2. Normally it's a decimal, which, looking at our z-table, that is going to tell us the probability. So let me actually pull up a z-table so we can have it. Alright, so I have a formula sheet that I'm going to post. Pull up. Since our z-score was 2, we're going to find the z-score of 2.0, positive 2.0. So right there, I don't know what just happened. So that's going to be 2.00 is right here. So 97.72, which is 97.72%. And then let's do the z-score for this one. Z equals 65 minus 60 over 5 would give us a z-score of 1. Looking at the table, a z-score of 1.00 would be 84.13. 84.13 percentage, and then we are going to subtract to find the probability, this gap. So that's going to be 13.59. 13.59%. Now let's look at the next question. Find the percentage of batteries that will not last 50 hours, which means anything less than 50 hours. So let's plug in the z-score equation. 50 minus 60 all over 5. That's going to give us -2. And that tracks, because that would be -2 standard deviations. This is going to give us the probability of going to -2.0, 2.28%. 2.28%. Is the company's guarantee? They guarantee it over 50. So the fact that there's only a 2.28% chance of it failing, I would say yes. I would keep it. All right, so this one's going to be a little bit different. Let's just go ahead and sketch it out like we did the last one. And we'll go a little bit quicker. That's our mean. Then we got 1, 2, 3 standard deviations. 1, 2, and 3 standard deviations. -1, -2, -3 standard deviations. The mean is 100, so that'd be 96, 92, 88. 104, 108, and 112. So the z-score is the z-score equation, and it just tells us how many standard deviations we are away. So find the probability that it's less than 103. Let's just draw it, and this is the only one that we'll draw on this one. 103 would be right here, so it's going to be under 1 standard deviations away, and it said less than, so we're going to find that probability. So we'll just use the equation. 103 is the data point minus the mean all over our standard deviation. That will tell us the z-score. That'll be 3 over 4, which is 0.75. So we want the probability, not just the z-score. So we take the z-score, go to our z-table, and go to 0.75. So we got 0.7. I wish that didn't happen. We got 0.7 right here. We got 0.5 right here. So we're just going to find the intersection point, 77.34, 0.75. 77.34. 77.34%. Find the probability that it's between 94 and 102. So we find the z-score for the bigger one first. And we find the z-score for the smaller one, 94 minus 100 over 4. That's -1.5. And we'll find the probability for each. So 0.5 is 0.50, 69.15, 69.15, and then -1.5, -1.5, and that's 0.50, 6.68. 6.68%. We just subtract them, and then we get our answer of 69.15 minus 6.68. 62.47. 62.47%. All right, is there anything else? I kind of want to keep this video short. I felt like that last one was pretty good. I'll do this one just because I see it should be pretty good. All right, read through it, and we see that the average is 70. Then we'll draw 1, 2, 3 standard deviations, which is 10, so 80, 90, 100. 1, 2, 3, 60, 50, 40. That's our mean, and that's 1, 2, 3 standard deviations, -1, 2, 3. All right, what percentage of young adults have a heart rate above, this is new, above 88? So we would go to like right around here, where 88 is, and we're going to look above. So that would be like 88. So we still use the z-score equation, 88 minus 70 all over 10. That's going to give us 1.80. This probability, when we look at the z-table, 1.80, 1.80 would be 96.41, 96.41%. That gives us the percentile, which is below. So we would just have to do 100 minus that to get our actual answer, because that is the percentile. So we end up getting 3.59%. That's above 88. It's a very small percentage. below, that's the percentile, so that one should be easy. 54 minus 70 all over 10, 16, negative 1.60. Go to our sheet, negative 1.60. That would be at 5.48%. All right, for this one between these two, well, we know the percentile of 88. The percentile, that's 96.41. We know the percentile of 54, 5.48. So the gap in between them, we would just subtract 96.41 minus 5.48. 96.41 minus 5.48, and we get 90.93. 90.93%. Okay. This one's a pretty good one. We know the percentage. We just need to figure out the z-score, not the z-score, the data point. So since this is the percentile, let's go to our z-table and just look for 80%, because 0.80 is 80%. The one closest to it, let me change colors. I see it's going to be somewhere in between 0.84 and 0.85. I'm just going to go to the one that's closest, which would be this one. So that's 0.84. So for this one, the z-score is equal to 0.84. And the equation for the z-score is the data point minus the mean all over the standard deviation. So 0.84 equals x minus the mean of 70 all over 10. We multiply both sides by 10. We got 8.4 equals x minus 70. Add 70, we get 78.4 equals x. That is the heart rate where 80% is lower. And then we already kind of, for F, we're going to use a previous answer because we already found the 88 beats per minute, which is 96.41% of people, but it's greater than. So we're going to be working with that 3.59 percentile and just multiply that by the 3,000 students. Because there's only a small percentage of students, so that's going to be 3,000 times 0.0359, 3,000 times 0.0359, and you get only 107.7 students. I'm going to round down to 107 people. Yeah, have a heart rate that is greater than 88 beats per minute. All right, that's the last one I'm going to do. Let me know if you have any questions. Bye.